start the second page of our review. We're going to continue simplifying radicals and performing the indicated operations. So on number 11, you notice that we've got adding and subtracting. We cannot do that unless we have like radicals. So these three have to be simplified. So we're going to keep the 3 out here, and let's look at the 18. 18 is just 9 times 2, because we do need perfect squares. Now, I like to finish this thought before I go to the other, but I mean, totally up to you. You can go straight across, but I like to look at this. The square root of 9 is 3, and 3 times 3 is 9. So there's 9 on the outside, 2 on the inside. So on this next one, I'll break that down and go a little bit slower. Okay, I've got the 2 on the outside. 8 needs to be broken down. Well, that's 4 times 2. Okay, so this is what I was talking about. This 2 is from the outside. The square root of 4 is 2, so that's a new 2 on the outside. And this one comes from here. Looks like we just have a bunch of 2's. So what we really have is these 2 multiply together and give me 4. So that's where I got the 9 from. I had 3 from here, and the square root of 9 is 3. Okay. Now, for 72. 72, if that's something that you're not familiar with, look at the fact that both of these ended up with 2 in the radical, under the radical. Be suspicious. You could go through and you could divide 72 by 2, and you find out that that's going to be 36 times 2, which is actually what you need. All right, so the square root of 36 is 6, and 6 times 3 is 18. So what I end up with is a negative 18 square root of 2. Okay, so I now have everything with square roots of 2, so I can just do 9 plus 4 is 13. 13 minus 18 is negative 5. Don't change your radical. You're just telling me how many square roots of 2 you have. All right, so when we move to 15, I've got cube roots. So again, I've still got to break them down. And when you see 375, when it's ending in 5, please be suspicious of our perfect cube that ends in 5, which is 125. 125 times 3 gives us what we need. All right, 5 is not divisible by 3. So I have to rearrange my variables. I have to go down to the next number that's divisible by 3, which is 3. That leaves 2 extra. Okay. So, and remember, this power can never be equal to or exceed that root. All right, and I could go ahead and finish this up. That cube root is going to be 5x on the outside, cube root of 3x squared. All right, over here, I've got to break up the 24. The perfect cube that goes into 24 is 8. Okay, so don't forget what you're doing. You need to do perfect cubes, not perfect squares. All right, and then we've got the 5x's again. So we still do 3 here and 2 there. So we're going to do the cube root of 8. X cubed is just 2x. And then we have left over again, cube root of 3x squared. Now, look, before we can proceed, all of this part has to be the same. So the stuff, the radical, the index, everything underneath, but also the x that's on the outside. So all of this has to be the same for us to actually do 5 minus 2. Right, so that's 5 minus 2 is just 3, and then you have to copy that part that was required to be the same. Okay, so there's that one. Now let's scoot down, and this gets a little bit more lengthy. We're still going to have to rationalize like we did earlier. So I'm going to come in here and I'm going to multiply top and bottom by the conjugate this time because this is a binomial. I need the binomial with the opposite sign because what that's going to do is it's going to eliminate my middle terms. Okay, so it's all of this times all of that. So the top here times that top, bottom times bottom. Okay, there are some shortcut rules for the denominator, but we'll use that over here on number 17. Okay, in the top, you just have to roll with whatever you get. And this one does turn into a mess. So 3 times the radical square root of 2, 3 times negative square root of 5. Okay, now when you're distributing this, you're going to, since they're both underneath, that's going to be square root of 20, and negative times negative makes positive, but that's going to be square root of 50. Well, don't forget, you can reduce those, so we're going to have to do that. Now, when we do the bottom, square root of 2 times square root of 2 is 2. And then that's going to give me negative square root of 10. The other one's going to give me positive square root of 10. And then positive times negative is negative. And the radicals cancel out, and it's just 5. Okay, so this was the plan of using the conjugate all along. These should eliminate. So you're not supposed to have any radicals in the denominator. Now, in the top, copy these down because these can't be reduced, but these two can. So let's do some in our head. That's going to be 4 times 5, right? The square root of 4 is 2. So the 2 goes out and the 5 stuck in. Now 50 is 25 times 2. The square root of 25 is 5 on the square root of 2. Okay. And in the bottom, I've just got 2 minus 5, which is negative 3. Now I still need to go further because now I have like terms. I have a square root of 2 and a square root of 2. So 3 plus 5 gives me 8. And then I've got these two go together. So that's going to be a negative 5 square root of 5 all over negative 3. All right, I'm not going to require that y'all do anything to mess with the negative. If you were going to make that look nicer, like if you're going to be taking upper level math, typically you don't leave a fraction with a negative in the bottom. What you would do would be apply that to the top so your signs reverse, and that would be 5 square root of 5 minus 8 square root of 2 over a positive 3. So that's the more sophisticated way to write the answer. If you give me this, I will take it, okay? This will just make me happy. All right, whenever we go over and we look at number 15, oops, it's not 15 that we need number 17. That's it. Sorry about that. So we also have to do the conjugate because there's nothing to reduce the way it is. So I've got to do square root of 3 minus x, square root of 3 minus x. Now make sure your top and bottom have to be the same because anything over itself is really just equal to 1. And when we multiply something by 1, we don't change the value. We are changing what it looks like though. Now the good thing here is this one cleans up very nicely. So actually I really don't even need an extra set of paper or a piece right here. That's just 5 times this radical, so that's that smush again. And then 5 times a negative x. And then when we do the bottom, let's do the quick way. All right, so square root of 3 times square root of 3 is just 3. We know the middles are going out, so all we have to do is the other end. Positive times negative will be negative, and x times x is x squared. There is nothing else that we can do to reduce that, so that's our answer. So now at this point, we're going to look at simplifying with the rational exponents. Now, you can put this in the calculator, so nobody needs to freak out. With the large calculators, the big TIs, it's actually easier. I prefer the little ones. Y'all know I don't like the big ones. But, and this would be what you would use in college algebra. If you were going to type it in, the only thing you've got to do is you want to use that little rooftop button for your exponent. Make sure you type your fractional exponent inside parentheses. Now, technically, you don't have to have the closing one, but as long as you wrap it up with parentheses, it'll work. Now watch, that's the real answer is 2. If I just did it as 8 rooftop 1 divided by 3, the calculator's not going to do it. Because what it's doing is it's going to do 8 to the power of 1 and take that answer and divide that by 3. So you have to group it so the calculator knows that that power is all one thing. You could even type number 2 in and the calculator give you the answer. Now, I would much prefer you be able to do it in your head. This is just, remember, roots on bottom, root or index, whichever way you want to talk about it, and the top one is the power, okay? So all this is the cube root of 8, which is 2. So that should not throw you off at all. Now, there's several different ways to do number 2. The way I would like for you to look at this is to notice that the roots are the same. Okay, these are both square roots. Okay, so put it underneath. Isn't that going to be 2 times 8? Well, the square root of 2 times 8 is 16. Square root of 16 is 4. And you're done. Now, this one is a little bit harder. So I'm going to put me a little extra paper underneath here so I can do this. We do need to swap to fractional exponents because nothing is the same right now. Okay? So I've got, let's see here, that's going to be 3 to the, that's the 1/2 power. Times, and this is 27 to the, let's see here, 1/5 power. Now, we've got to get something the same. Either the bases need to be the same, the denominators, one or the other, okay? So we need to rewrite 27 as 3 to some power, because we can, All right, so hopefully that dawned on y'all that 27 is 3 to the third. Now I'm going to make this lengthy so you can follow me. So this little 3 to the 1/2 is just sitting here being patient. When you multiply this, raise a power to a power, you just multiply them. So that's just 3 to the 3/5. Remember, powers on top, roots on bottom. Now the rule says when you're multiplying like bases, you have to add your powers. So I'm really working with 3 to the 1/2 plus the 3/5. Okay, so I need to add those fractions. Now, a bunch of people do them different ways. I think the easiest way I've seen this represented is, hopefully most people know the common denominator is 10, but multiply this one by the 5 that you need, and this one by the 2 that you need. And you're doing top and bottom again, because that's like multiplying by 1. So this one gives me 5 over 10, and this one gives me 6 over 10. So now I got common denominators. So I got 3 to the 11 over 10. I will take that, but in math, just know that it is common policy in upper level courses, whatever form you are given, that is the form you are expected to leave your answer in. So they gave radical form. We really should leave it in radical form. So remember power, and there's my root, okay? Now, technically speaking, if you want to get I'm happy with these answers, but if you want to get technical about it, that can be reduced, right? Because this says I need 10 to get out the door, so I can put 10 of them here and 1 of them there. So that gives me a 3 on the outside and 1 on the inside. So if you want to give me the best answer, would be this right here. But I will take either one of these right here. Now, when you get to number 4, it's actually easier. Remember, that's just a cube root. Rewrite it. Now, let's see. Do we need to split anything up? Well, 64 actually is a perfect cube, and 12 is divisible by 3. So the only thing we've got to pay attention to is that the cube root of a negative is a negative. Cube root of 64 is 4, and 12 divided by 3 is 4. So that's all we had to do. Okay, so let's start looking at, I'll tell you what, let's end this one here, and then we'll start looking at the equations, okay? So I'll see y'all in the next one, and that should wind it up.